Technigas MK3 cargo tanks are of double-membrane prismatic type, built in accordance with the IGC code. The tanks have an octagonal transverse section matching with the supporting inner hull and are situated inline from forward to aft. Each tank is located in a hold space formed by two transverse bulkheads. The tanks are equipped to carry LNG at cryogenic temperatures and at a pressure that is marginally higher than atmospheric pressure. They are insulated to reduce cargo loss through natural boil-off. The materials used for the containment system are required to reduce the heat transfer from the hull structure to minimize the boil-off gas from the cargo, as well as to protect the hull structure from the effects of cryogenic temperature. The system ensures that the whole of the cargo hydrostatic loads are transmitted through the membranes and insulation to the inner hull plating of the ship. The function of the membranes is to prevent leakage, while the insulation supports and transmits the loads, in addition to minimizing heat exchange between the cargo and the inner hull. The basis of the membrane philosophy is that, in the event of a leak in the primary barrier, a secondary barrier will contain the cargo indefinitely. Thus the system has two identical layers of membranes and insulation. These trunk spaces are used for inspection and the passage of electrical cables and various piping systems. The cargo tanks are connected with each other by the liquid, vapor and spray headers, which are located on the trunk space. The nitrogen headers supplying the primary and secondary insulation spaces and other services directly associated with the cargo system are also located on the trunk space. The spaces between the inner hull and outer hull are used for ballast. The ballast tanks will also protect the cargo tanks in the event of an emergency situation such as collision or grounding. The ballast spaces around each cargo tank are divided into port and starboard double-bottom wing tanks, which extend to the side of the cargo tanks as far up as the trunk spaces. The port and starboard ballast tanks are separated by a pipe tunnel or pipe duct space extending the full length of the under-tank area. The primary membrane is in contact with cargo. It has an orthogonal system of corrugations which compensate for thermal contraction and mechanical ship's deflections. The corrugations have a nominal pitch of 340 mm in both directions, but in practice, large corrugations are used in the longitudinal direction and small corrugations in the transverse directions. The membrane is made of nickel steel alloy with very low carbon content, SUS 340L, and is 1.2 mm thick. Angle pieces of 90 degrees and 135 degrees are provided for the tank corners to ensure the continuity of the corrugations. This is also called as the inter-barrier space, IBS, as it is located between the primary and the secondary barriers. Rigid polyurethane foam with reinforcing glass fiber is packed in between two plywood sheets. The insulation transmits cargo pressure to the internal structure of the vessel. The prefabricated insulating panels are of 270 mm thickness. This is also called the insulation space, IS, and is located between the secondary barrier and the inner hull. It is made of laminated composite material called triplex, where an aluminium foil is embedded between two glass cloths. The aluminium foil provides the tightness, while the glass cloths give the required resistance. The thickness of primary and secondary insulation is governed by the designed boil-off rate of 0.15% of the total cargo tank's volume per day. The secondary membrane, like the primary membrane, is made of flat nickel steel alloy sheets of 1.2 mm thickness. In case of a leak in the primary membrane, it can contain the cargo indefinitely. It is located near the ship's centerline at the aft part of the tank. A stainless steel tripod mast is suspended from the liquid dome. This mast is held in position at the bottom of the tank by a sliding bearing to allow for thermal expansion or contraction depending on the tank environment. The pipes running from the tripod mast pass through liquid dome. Normally the liquid dome is filled with nitrogen. A gas or vapor dome is located near the geometrical center of each cargo tank ceiling. It has the vapor supply or return line which supplies vapor to the tank when discharging and vents vapor from the tank during loading or venting boil-off. It has 2 spray valves for cooling down purposes and 2 pressure or vacuum relief valves. It also houses the pickup for pressure sensors and the purge line from the discharge pipes of cargo pumps. It consists of the main loading and discharging pipes in the form of a 3-legged trellis structure and is used to support the tank access ladder and other piping and instrumentation equipment. The instrumentation includes temperature and level sensors, high and low level alarm sensors, and cargo pump electric cables. 2 cargo pumps are mounted on the base plate of the tripod mast, and 1 spray pump is mounted on the lower support of the tripod mast. Emergency pump column and a float gauge column are also located in the tripod mast. These are submerged electric 2-stage cryogenic centrifugal pumps. 1 pump is installed in each tank. It is used for tank and line cool down, for forced vaporization of cargo, and for stripping the tank. They are started and stopped from the cargo control room. They will be automatically stopped in case of an emergency trip. Normally, this pump is started at approximately 0.7 meters to avoid possible starting problems. These are submerged electric single-stage cryogenic centrifugal pumps. 2 pumps are installed in each tank and used for cargo discharge. They are started and stopped from the cargo control room. They will be automatically stopped in case of an emergency trip. Normally, full discharge rate is maintained until the tank level reaches approximately 0.7 meters, at which time the pump will start to cavitate. The different components, reinforced polyurethane foam, plywood and secondary membrane, are bonded together with a polyurethane adhesive. The backing plywood of insulation panels are intended to be bonded on the double hull. The upper face plywood of insulation panels are used to fit stainless steel strips for the membrane fastening and also to support the membrane. Epoxy glue is used for assembling the insulating elements. Load-bearing mastic is used for the supporting of insulating panels. Polyurethane glue is used for the prefabrication of the insulation panels. The 12 mm plywood is used at the verso face in the fabrication of the insulating panels and top bridge pads. The 9 mm plywood is used for the fabrication of the insulating panels. The 92 mm plywood is made by the bonding of several plywood panels of 15 mm nominal thickness. This plywood is used for the fabrication of hardwood keys. Epoxy glue is used for assembling the insulation elements. Load-bearing mastic is used for the supporting of insulating panels. Polyurethane glue is used for the prefabrication of the insulation panels.